Okay, so we are going to look at long division, but this time with polynomials. And it's going to look a lot like long division with numbers looked. So let's say we've got this problem. We've got x squared plus 5x plus 4, and we're going to divide it by x plus 4. Okay, so notice first of all that our polynomial needs to be in descending order. That means your biggest exponent needs to come first, and they slowly get smaller until you get to your constant. Now, if you think about this, we know how to answer this problem, actually. So like side note over here, if you were going to take x squared plus 5x plus 4, and we were going to divide this by x plus 4, we would factor the top, right? We'd be like x plus 4 times x plus 1, and we would divide that by x plus 4, and we'd be like, yo, these cancel, so the answer is x plus 1. So, okay, we actually know how to do this problem, but we're going to learn how to do it with long division, and we're going to do that because this method only works for these nice little quadratics that we can factor really easily. So we need a backup method that we can apply to bigger polynomials. So long division is a solution. So we're going to set this up like a long division problem. X squared plus 5x plus 4, and we're going to put our x plus 4 on the outside. Now, the first thing we're going to look at is our x squared and our x. And we're going to follow those same steps. How many times does how many times does x go in to x squared? And what is the answer? The answer is it goes in x times, right? Because x times x is x squared. Multiply through. X times x is x squared. X times 4 is positive 4x. Now, the subtract step. When we subtract, we're going to subtract the entire thing. So careful here. X squared minus x squared is nothing. And 5x minus 4x is x. Okay? Bring down the 4. It's a positive 4 plus 4. Okay, now, as per usual, we're working with the x now. So x goes into x how many times? It goes in 1 time, plus 1 specifically. Okay, multiply through. 1 times x is x. 1 times 4 is 4. Subtract the whole thing. X minus x is 0. 4 minus 4 is 0. So our remainder is 0. Our answer is right up here where it always is. And we know that x plus 4 is a factor. And we know that now because the remainder was 0. And having a remainder of 0, we know, means that whatever you divide it by is a factor. Okay? Let's try it again. Okay, this time, let's say we're going to take x squared plus 3x plus 6, and we are going to divide it by x plus 1. And really, the reason we're dividing is because we want to know, is x plus 1 a factor? Okay, and the reason we want to know that is because that's usually where we can find our x-intercepts, right? Factors lead us to x-intercepts. That's super important, super important. So we're going to set this bad boy up. All right, we're going to say x plus 1. And we're going to say x squared plus 3x plus 6. Make sure you're in descending order. You are. We're going to start with x squared and x. How many times does x go into x squared? It goes in x times. X times x, x squared. X times 1, x. subtract the whole thing. Be very careful. Eventually we're going to have negative signs and it's going to make a mess. X squared minus x squared is 0. 3x minus x. Well, 3x minus 1x is 2x. Bring down the 6. Okay, so now we're dealing with 2x plus 6. Okay, well, really, we're dealing with 2x. Let's be clear. Okay, x goes into 2x how many times? It goes in twice. Okay, 2 times x is 2x, and 2 times 1 is positive 2. Subtract the whole thing. Notice how I'm putting brackets? There's a reason. 2x minus 2x is 0. 6 minus 2 is 4. Is there anything left to bring down? No, I'm done. And this time, I have a remainder. Well, what did we do with remainders when we were dealing with just numbers? We took that remainder and we put it on top of the fraction. In this case, what goes on the bottom? You find the bottom of the fraction right over here. So the bottom of my fraction is 4 over x plus 1, which, by the way, is totally allowed. It's just a rational function. So the answer to this question that we were originally asking ourselves is this. If you divide by x plus 1, the answer is x plus 2 plus 4 over x plus 1. That's the answer. So therefore, is x plus 1 a factor? Is it a factor? And the answer is negative, not a factor. Okay, we're going to try one more with negatives just to see how crazy our world can get. Okay, 3x squared minus 4x plus 7 divided by x minus 1. Okay, people, we're getting rowdy here. All right, set it up. X minus 1 on the outside. 3x squared minus 4x plus 7. So we're looking at this 3x squared and our x. X goes into 3x squared. How many times? 3x times. Multiply. 3x times x is 3x squared. 3x times negative 1 is negative 3x. Subtract. 3x squared minus 3x squared is nothing. Negative 4x minus negative 3x. So if you subtract a negative, it's like adding. So negative 4x plus 3x is negative x. Bring down the 7 plus 7. Okay, now we're dealing with this negative x. X goes into negative x how many times? It goes in negative 1 times. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Subtract. Do you see now why I've been drawing these brackets? Because now I've got a negative and a negative, right? Okay, so to subtract negative x minus a negative x, remember that's like adding. So negative x plus x is 0. 7 minus 1 is 6. So here's my remainder. And remember, I'm going to put that over the number, what I was dividing by, and what I was dividing by is x minus 1. So the answer to our problem is 3x minus 1. It's a positive 6, so plus x minus 1. Is this a factor? Is it? Nope, because we got a remainder of something other than 0. Okay, that's all I got. Good job.